Okay, FINA 510 students, I just wanted to make a little video discussing those arbitrage questions we didn't quite get to cover in depth at class last time. So I've got three securities, security A, B, and C, and their prices, and then the time in which they receive these cash flows. So this is perpetuity or an annuity, a 3 period annuity. This is a lump sum after year 3, and then this acts more like a bond. So we have 3 different securities here and 3 different prices. So the question is, for an arbitrage question, it always is, can I create one or more of the securities using another set of securities? So can I replicate the payoffs from one group with the payoffs of another group? So if we just look at this here is a stream of $10 payments and a $100 lump sum at the end. And that looks something like this here. And so we can kind of intuitively think that maybe we're going to combine these two things, A and B, and get security C. So what we need to do an arbitrage question is to decide on an amount of securities of each type to buy, and then the cash flows that we get in each period. So let's say I bought one of this, and one of this. Well, I can figure out my total cost. It's going to be the price times the amount for each of the securities. So we get a total price of $141 if we bought those. And similarly, we can figure out the cash flow. So if I buy one A, I'm going to get $10 in the first year from A. And then I'm going to get $0 in the first year from B. And $10 in the first year from C. Since we want those amounts to stay put, I'm going to lock those in. So if I buy one of A, one of B, and one of C, I'll end up with $20 worth of cash flow in year 1, 20 in year 2, and 130 in year 3. But notice we started out with this idea that we might be able to make this one using these two. So if I bought one of these and then sold this one short, I've eliminated these two cash flows and I have a $90 lump sum payment at the end. So if I actually increase this to 10, now my cash flows have netted out. So if I take one of these, 1A, and I take 10 of these and combine them, I get 10, 10, 10 plus 100, and you get 10, 10, 110, and you'll end up with the same cash flows as security C. And we've done the prices, and you end up with $3. So because you sold essentially this is 80 plus 28, that's 108. So you paid 108 and received 105. So you had to pay $3 to get nothing. So if we reverse this, 1, negative 10, negative 1, if we sell these short, now we'll receive money for 0 cash flows in the future. So this would be what the textbook describes as a money machine. But let's give some thought process to where I would get these numbers from instead of eyeballing them. So a way to systematically do that is to decide which set of securities is going to replicate another security. And you don't have to know the amounts. So we know roughly that this, say, was going to be positive. So this one we thought we were going to be buying these and maybe selling those. And we had this general idea of how we would get there. And so and I'm gonna let me just make these cash flows a little more interesting so that this becomes a real problem. So what if this pays 8, 8, and 8 instead of 10, 10, and 10? So we're gonna buy some amount of these and some amount of these and some amount of these. All right. So I have an $8 cash flow here and a $10 cash flow here and a $0 cash flow here. And we want these things to net out. So the process to decide how much of this to buy is let's just arbitrarily set our single security that we think the other two will replicate to 1. So we're going to get one of these. And, you know, if, as we found before, one of these plus 10 of these was going to replicate one of these. It would be also true that 2 and 20 would replicate 2 and so on. So it doesn't really matter how many of 1/2 of this you buy. So we might as well just do it, keep it simple and buy 1 and then figure out how many we would need of the others to replicate exactly 1. We know we want this $10 cash flow to cancel. And so that means for every $10 of security 1, I need to buy $8 of security 2. So I'm going to take 10 and divide by 8. And so if I buy 1.25 of security A and 1 of security C, 8 times 1.25 is 10. 10 minus 10, you'd end up with 0. Okay, so to figure out the amounts, I took one cash flow divided by the other. Now what about this over here? So if I want this amount, I know that I'm already paying 10 here. So the amount I want is the amount I need, which is 110 minus this payment up here. We know we're buying 1.25 of these, so I do this and that. So that's the amount that so we start with needing $110 in year 3, and we subtract off the 1.25 times 8 that we're going to make from security 1, and so the rest has to be made up by security 2. And so that's the total number of dollars we need, 110 minus 8 times 1.25. But we want the total number of B's we need. So we need to divide by dollars per B to get it to all work out. So and dollars per B is this cell right there, 10. So it ended up 110 minus the quantity 8 times 1.25 is equal to 100. And we need 10 tens to match the 100. So we're going to pay $220 to get that done. Let's put this in as a short position, and we can see. So we're going to end up paying $10 to not make any money, which means to make arbitrage profit, you want to short these and go along this. Now we're getting money up front. So in general, when you've got an arbitrage question, you want to figure out which securities you need to combine to replicate another one, and then look at each individual cash flow and find the amount of the number of that security you have to end up with the 0 down here. So I did this piecemeal. So I made this first 0, 0, by changing this number, and then I made the second 0, 0 automatically by doing that, and then the third one I made 0 by changing the second number. So that's the simplest introduction I can come up with to do an arbitrage problem, and we'll work through a more complicated version of this type of problem in the next video.